Welcome back. We're going to continue our discussion on a brand new topic, and that'll be aldehydes and ketones. Now, before we get too far into the topic on learning how to synthesize aldehydes and ketones, or the reactions that aldehydes and ketones themselves undergo, let's actually take a moment to refresh our memory on how did we learn to name compounds that contain either an aldehyde or ketone or both. Okay. So let's start with the generic structures for an aldehyde and a ketone. We know that they both contain the carbonyl group, which is the carbon containing the double bond O, right? That's what makes a compound an aldehyde or a ketone. Now, typically for an aldehyde, not typically, always for an aldehyde, the C double bond O is at the end of the chain, whereas C double bond O for a ketone is somewhere along the chain, but not on the end of the chain, right? Now, if our compound contains only an aldehyde group, then the last name ends with an al, provided that's the higher priority group. And if our compound contains only a ketone, then we know that the last name ends with a known, provided ketone is the highest priority group in that chain, right? Now, I have given you a bunch of problems here. I'll work out a couple, just to refresh your memory. But then I want you to try a few on your own as part of your My Thoughts assignment, right? All right, so let me start with B, because I think that's one problem that's persistently given issues to some of you, if not everybody. What's the first thing we do? Or whether it's naming or whatever we do, we figure out how many carbons are there in the longest chain possible, right? Now, we're not numbering, we're just putting dots. Just to count 3, 4, 5, and 6, right? Which side should we start numbering from? Well, the side that contains the highest priority group, provided that higher priority group is more towards the end of the chain, which means we start numbering from this side, because ketone is a higher priority group compared to a double bond. And you're wondering, well, where's that chart? Well, for your convenience, I have it right here. So you do not have to go back, run through your notes, but if you do have that chart from last time, good for you. If not, you are welcome to use this chart to solve the rest of the problems, right? So now we know that from our priority chart, the ketone group is a higher priority group over a double bond. We know that double bonds are enes. We have hexane, so it's hexene, but where the double bond is between 4 and 5, so it's 4-hexene. We have to account for the exact position of the double bond, and that's 2. That's the position where the double bond O is, and then it's a ketone, so it's 2O. Remember that? Many of you are able to pick it out if it was already done for you in the choices. Only few of you are actually able to write it out from start to finish for this particular compound, and I believe an alternate version of this was on the test. Okay, I'll do F. Okay, so again, which side should we start numbering? Well, we can start numbering, technically, in this case, this is sort of an odd thing, because even though, aldehyde is also a higher priority group, if you actually go back, aldehyde is actually in the higher priority group, so there should be no issue. So we start from this side. So 1, 2, 3, 4, 5, and 6. So again, we have a 6-carbon compound in the longest chain possible. Some of you were numbering here. If you remember, don't do that. You don't number the oxygen. So that's hexanal, right? So hexanal, right? Because hexane is large, and then we replace the E by the highest priority group's last name. In this case, it's aldehyde. So it's hexanal, and we can write 1-hexanal. Okay? But then the ketone is in the 4th position. And ketone, when it's a low priority group, it's called oxo. So it's 4-oxo, 1-hexanal, right? That's the name of it. So I want you to try A, B, D, and C. as part of your My Thoughts assignment. And that's kind of where I want to start as far as introducing the idea of aldehydes and ketones. And when I come back, I'll see you with the synthesis of aldehydes separately and ketones separately. So stay tuned for those.